Now let's talk about some special techniques for finding integrals. So on this one I have x plus 1 divided by the square root of x, and I'm taking the integral with respect to x. Now you want to be careful with stuff like this. We don't have a product or a product or a quotient rule for integrals yet. So in a situation like this, if you've got a monomial on the bottom, you could always split this up into the integral of x over the square root of x plus 1 over the square root of x with respect to x. And x divided by the square root of x is actually just the square root of x. So I could split this up and have the integral of the square root of x with respect to x plus the integral of 1 over the square root of x with respect to x. And I can make this one x to the 1/2 power and this one x to the negative 1/2 power. So this first integral would be x to the 1/2 plus 1 over 1/2 plus 1. And the second one would be x to the negative 1/2 plus 1 over negative 1/2 plus 1. And this is all plus c. So this will be x to the 3/2 over 3/2 plus x to the 1/2 over 1/2 plus c. And if I flip my fractions, I get 2/3 x to the 3/2 plus 2x to the 1/2. And if you left it there, that would honestly be fine, but most people tend to go ahead and at least write this as the square root of x. I would be fine if you left your answer here. Some people will actually factor out the 2 square root of x and just write this as 1/3 x plus 1. That's fine. It's not really necessary for this problem, but you can do that. So just be aware that you can do that. One thing that's important to note is that the integral of a quotient is not equal to the quotient of the integrals, so do not do that. Don't try it. You will get it wrong. But if you have a situation like this with trig functions, sine over cosine squared, we could go ahead and break this up into sine of x over cosine of x times 1 over cosine of x with respect to x. And the sine of x over cosine x is tangent x, and the 1 over cosine of x is secant of x. So this is going to be the integral of secant x tangent x. I'm just reversing it so it fits our form, which we know is secant of x plus a constant c. So sometimes you will have known forms in hiding. And you kind of want to think of yourself with integration as a sculptor. You're trying to take your expression or your function and sculpt it into something that meets a formula that you know. That's kind of the goal here.